Okay, check this out. This is the latest project here in the shack. Got one of these $50 NanoVNAs. Vector Network Analyzer. Probably can't see it because it's really tiny. But we've been having issues with multi-pole crystal filters lately, IF filters. So here's a little fixture I put together, and a crystal filter I just got in the mail from a friend of Alan's, who said try it out. If it works, send me some dough, and if it doesn't, send it back. And then sure enough, it works great, so I'm more than happy to send him the dough. Anyway, it's a lower sideband filter for my T-4XB Drake transmitter. So use the VNA. This is specified to be 1 kilohertz or 1 kilo ohm input-output impedance. And the system here, of course, is all 50 ohms. But the cool thing here is the software. Let me pause this for a second. Okay, I don't know how well this is going to come out, so we'll keep it short and sweet. But using the VNA here and matched impedances of the filters, we get a trace showing there. And if you can see the markers, there's 3 markers. On the left is a little green one up near the top, and a blue one to the right of that, and then a red one. The green and the blue mark a 2.4 kilohertz passband, and the red one is on the center frequency. So we can tell that this filter is probably going to work just fine. There's a bunch of data that comes with it, just about anything you'd ever want to know. And there's other graphical displays like return loss and so forth, phase, that you can call up. But I was just interested in the attenuation plot. So let me pause this again. Okay, now we're going to do a little RF testing, or at least try to get an idea what this thing might look like. So what I've got here is my wideband noise generator, my old trusty noise bridge here. The filter mounted in the fixture, and you can see in the fixture here I did a little impedance matching to hopefully get it a little bit closer to 1,000 ohms. So we transition from 50 to 1K, hopefully without losing too much. And it seems pretty reasonable. Of course, I don't have a whole set of calibration loads built up for this impedance, and I'm not going to do that, but this is all just going to be relative anyway. So what I have here is a series capacitor and a shunt inductor made just from whatever toroids I had available here that were in the right frequency range. So these turned out to be T60-2s and 34 turns and 130 picofarad cap. So that's the network on each side, and hopefully that should transition us up pretty close to 1K from 50 ohms. And the output of that goes to the receive antenna port on the K3. So let me get that set up. Okay, we're almost set here. We've got the old K3 set up to 5645, the ideal center frequency of the IF filter. Now there's, tolerance to everything, so keep in mind none of this is lab quality stuff. We're just looking for general response here and trying to glean as much information as we can. So I'm going to turn on the noise generator, and we'll focus up here on the pan adapter, and hopefully we'll get a let me try to raise this a bit. This is always a challenge to try to get it to focus. I'm even on the backlight setting. If I move that out of the way. Anyway, the green area that you see shaded there represents 2.4 kilohertz from 300 hertz up to 2.7 kilohertz. So let's turn on the noise. And you can see here, I hope, that we get a pretty favorable response, all things considered. I'd call this a pretty good filter. Again, I'm sure that our impedance stuff is off a little bit and all that's going to have an effect. But when I jumper out the filter, my reference line is minus 70 dBm. So I have probably less than 10 dB of insertion loss and a little bit of ripple across that pass band, but it's not too bad. I think if my impedances were a little bit closely more matched, I might have a little more carrier suppression right at the center frequency here. But I'm sure a lot of that is just fixturing, so who knows. The bottom line is, I think it's fair to say that this is probably going to be a pretty good sounding lower sideband filter. The green, again, the green shaded area is what the filter was designed to do, 2.4 kilohertz from 2700 hertz to 300. So I think this one's going to sound pretty good. Anyway, that's kind of how I've been fooling around trying to tell whether filters are good or bad without, you know, a lot of test equipment. Just the noise generator, little homebrew fixture, the right transceiver and accessory, and that NanoVNA is just the coolest little thing. It really is. Hard to believe. I might have to get another one just to have as a backup, because it is pretty fragile. But for what it costs, it's unbelievable. Anyway, that's it. Keep on tinkering. This is a good one. I'm going to put it in the T-4XB, and I bet it's going to sound just great. So thank you there to Donnie. I don't forget your call, but a friend of Alan's out in Nineland someplace that sent me this filter, and I think it's going to work just great. See y'all later. Keep tinkering.